Okay, this is section 6.2, busy intersections, more perfect unions operation on sets. So like I said in the first video, normally we will start with prep skills. And so that's what this set is going to start with. Now, for purposes of time and just because this would be very meticulous for me to unveil the answers down here, I'd have to cover and color the font. So I just left skill number 5 for you to go back and look at for yourself. But skill number 1, write the set of days using the roster method. So remember, the roster method is when you identify your set with a capital letter and you list the elements using braces. So this is the set. Whoops, I don't want that. Okay. So W for the week, days of the week, and then list all the elements: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. No matter where you start. Okay. Write the set of even integers greater than 5, again using the roster method. So this is what you should have come up with. E for even numbers. Skill number 3, write the set. Now I'm going kind of fast, but realize you can pause the video at any point to write your answer and then unpause it. Skill number 3, write the set 4, 5, 6, 7, 8, 9, 10 using set builder notation. So this is the one that's kind of weird. And so this is what you would end up doing. These are your natural numbers, or counting numbers, but natural numbers. So we identify, we're looking at the set of natural numbers, and then the elements we're going to look at is the set of all x such that x is an element of the natural numbers, and the value of x is, whoops, I messed up here. The value of x will fall between 4 and 10, and it does include, that's why I had to change that to include the equal to. So we can let x equal 4, 5, 6, 7, 8, 9, and we can let x equal 10. Okay. Now use inductive reasoning to predict the next 3 numbers. So 4, 8, 16, 32, 64. So if you can recognize what the pattern would be, here are your next set of numbers. And then 10, 30, 50, 70, they're going by 20s, starting at 10. And so that would be your next 3 sets of numbers. And then here are your powers of 4. Now, I do want to make a comment. Please make sure, if you haven't done so already, please make sure that you are doing whatever you need to do to get a TI 84 plus calculator. You will be needing it pretty soon. And there are things that you will not be able to do by hand. If you do them by hand, you are going to be doing a lot of number crunching, and you're going to run the risk of not entering a number incorrectly, or not putting a parenthesis or a bracket or however you group. You're going to run the risk of not entering information in the calculator as it should be, which means you're going to mess up your numerical answer at the end. So again, please make sure you check with the library to see if they have any that you can check out for the duration of the semester. At this point, I seriously doubt that they do have any available, but go check. Okay, so 6.2, here are our learning objectives. So we're going to find the complement in all subsets for a given set. We're going to evaluate set statements involving subset notation, and then perform and apply set operations that involve union and intersections. And we are going to be looking at Venn diagrams, okay? All right, so the universal set. The universal set is a set of all objects in the universe. It's symbolized by U, which is a set of all objects that are reasonable to consider in that situation. So again, if we went back and we talked about the members in our classroom, we could call each person an element. We could call them an object. I could refer to the entire class as the universe, because that's what we would be looking at, and then we could break that down into different types of subsets. Okay, so if every element, so if I were to take a subset of our class, okay, let's say that I took a subset of people who wore glasses in our class. So if every element is a set of A, if every element of a set A is also an element of set B, then A is called a subset of B. So what this means is set B would be representing our entire class. And set A would be the people who wear glasses. So everybody who wears glasses, that's set A, they are also an element of set B, which are the people in our classroom. So set A is a subset of B. Then we use this symbol, which is used to designate a subset, and then we write it like this, and it's read that A is a subset of B. Okay. Now, if set A is a subset of B and is not equal to B, now remember the difference between equal and equivalent. Equal means they have the same elements. Equivalent means they have the same number of elements. So we're talking about the same elements here. Okay. So if set A is a subset of set B, but it's not equal to B, then we call it a proper subset. Now, I've given an example here. And here's the example that I'm talking about. So if we have set A as the color blue, the colors blue, red, and gray, and B are the colors red, yellow, blue, and gray. Notice that all of these colors, blue, red, and gray, are in the set B. Blue, red, and gray. Then A is a proper subset. And then we write it. That means that A is a proper subset. Now notice the difference between how this looks. We don't call it a subset, we call it a proper subset. So it's going to be without the line underneath. Okay, so that means that A is a proper subset, which means that A is a subset of B. And it is because notice how all of these elements, blue, red, and gray, are in the set of B colors. But A does not equal B. Now, again, remember, if it equals, they have to have the same elements. And notice the element that's missing in A is going to be yellow. And that's why we call that a proper subset. Okay, and there was an example here that I did for this one and I forgot. So if we were looking at a subset, A would be the colors blue, red, and yellow. B would be the colors red, yellow, and blue. Now notice how they are equal. They have the exact same elements. Then A is a subset of B, and we can use this notation that A is a subset of B. In this case, we would use this notation to say that it's a proper subset, which means that that A would not be equal to B. Okay, so be careful with that. All right, the intersection. The intersection of two sets, A and B, are symbolized by this notation. This is read A intersect B. And that means it's the set of all elements that are in both sets. So A intersect B, the elements of A that also intersect the elements of B. They have to be common to both. So in set builder notation, what this means is that A intersect B means the set of all X such that X is an element of A and X is an element of B. So it has to be in both sets. So intersection, the elements are in both sets. And then I gave you an example. So I said if P is the set of numbers 1, 2, 3, 4, 5, and Q are the set of numbers 3, 4, 5, 6, 7, then P intersect Q means I only want the values that are common to P and Q. The intersection of two sets is the set of all elements that are in both sets. The only numbers that are in both sets are 3, 4, and 5. and then 3, 4, and 5. So that's why P intersect Q is 3, 4, 5. Now, the union of two sets, A and B, are symbolized by A union B. And that's the set of all elements that are in A or in B, or they could occur in both. So in set builder notation, this is what it looks like. A union B is the set of all X such that X is an element of A or X is an element of B. Now, the example that I always use in class is when my wife and I got married. My wife had, after we got married, we moved into a house, and she had all the stuff that she had when she lived by herself, and I had all the stuff that I had when I lived by myself. Well, there were some things that she had that I didn't have. So, like, she had a washer and dryer. I had the dog. She had some dishes. I had some silverware. She had a bed. I also had a bed. Okay. She had a TV. I had a TV. So there were some things that only she had that I didn't, and vice versa, and some things that we both had. So when you look at the union, think of the union as a marriage, and you bring everything together. And it doesn't matter who has what. It's all being brought together. Okay. And so here's the example that I gave you again. I used numbers. Oops. That's a second. And I saw that clearly. Okay. So if we let P again be the set of numbers 1, 2, 3, 4, 5, and Q is the set of numbers 3, 4, 5, 6, 7. If I want the the union of these sets, I want everything. So I want all that set P has, which are the numbers 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, there they are. And I also want the set of numbers that Q has, which are 3, 4, 5, 6, 7. And here it is, 3, 4, 5, 6, 7. So P union Q are all of these numbers. So notice how you just bring everything together, you combine it all. Okay? All right. Now, let's look at this first example where we start to talk about Venn diagrams. So hold on just a second. Hold on just a second. Okay. I don't know if it really paused it or not. Okay, so example one. Well, Venn diagrams are named after a man called John Venn, who came up with the concept in the 1800s. So let's look at example one. If U represents a set of natural numbers, so those are our counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, then only those elements we can use to define other sets have to be from those natural numbers. So whatever I do, I can only limit myself to these numbers. If I go outside of that, then I run the risk of using values that are not in this set, which means I am looking at an empty set, things that aren't in my normal set. Okay, so the universal set from which the elements that can be chosen are going to be these numbers. So we just put it in roster form. Using the roster method, I listed my sets. Okay. And then I don't know why that says examples D, E, F, G. I think something that it should be A, B, C, D. So you'll have to just write over that. A, part B, part C, part D. Okay, so the next one, let me see if I can do this real quick. Oh, that's fine. Okay, so part A was just listing the sets. Okay, the next one is going to, for part B, is going to be the set A. If we look at our Venn diagram, the set A, look at what's inside our circle. So it's just the numbers 2, 4, 6, and 8, which are our even numbers. Okay, and the elements that are not in A are going to be what's outside of the red circle, which are the numbers 1, 3, 5, and 7. But notice that it's still part of the universal set. Okay, so we call the elements in U that are not in A, so the elements that are in U but they're not in A, we call them the complement. And then we denote it by A prime. Okay, so now for part D, we're going to write that using our set notation, our set builder notation. And this is what it's going to look like. So when we talk about the elements that are in A prime, which are the ones that are outside of A but still inside of our universe, we're calling A prime, we're saying that X is a set, or the set of all X, such that X is an element of U. X is an element of the universe, 1, 2, 3, 4, 5, 6, 7, 8, which it is, and X is not an element of A. So it's not part of A, but it is still inside the universe, which is 1, 3, 5, 7, and that's the complement. And that's how you write the complement using the roster notation, set notation, excuse me, set building notation. Okay. Now, these examples I went ahead and typed up, so this is going to go by really quick. Example 2, the list of top 10 teams from the final AP Top 25 College Football Poll for the 2018 season is listed. Boy, that's a lot to say. Note that a record of 11-2 means that a team won 11 games and lost 2. Okay, so they start us out by looking at this universal set. Clemson University, University of Alabama, Ohio State University, Oklahoma University, University of Notre Dame, Louisiana State University, University of Georgia, University of Florida, University of Texas, and then Washington State University. And then they've also given us D to be these 3 universities: University of Alabama, Ohio State University, and University of Notre Dame. So for sets U and D defined above, that's what we're going to be using for all of this. Find the set D prime using proper notation. So D prime, this is D. Now notice that D is also inside of my universal set. They want D prime. So out of this universal set, I want all the universities that are not in D. Okay, you can pause right now, pause the video so that you can write this out on your own. This is what you should have gotten. D prime are these universities. Now, when we draw the diagram, we draw a Venn diagram that illustrates the set. So my universal set is all of this. So in D, oh, I messed up. This should read D prime. So that's an easy thing. D prime. Okay. Now it's fixed. Okay, so we have D prime are all of these colleges and universities. This are the 3 colleges that are in set D. Here they are. Okay. And then notice that they're all still within our universal set. Okay. All right, now C, it says using the roster method, write the set W of all teams that won 11 or more games. So we're going to look at their record here. So as long as the first number is 11 or higher, that means they won 11 or more games. So I'll let you pause the video. Okay, this is what you should have gotten for set W. for these teams. So that means that for W prime, these are the teams that won less than 11 games. So again, I'll let you pause the video. Okay, and these are the three teams that you should have come up with. So losing less than 11, LSU, they only won 10. University of Florida only won 10, and University of Texas only won 10. So those are the three. And then here is the set W, which is part C. And then W prime would be those teams that are outside of W, but still within the universal set. So I hope you can see it's really pretty easy on how to write these, okay? All right, now we're gonna continue to use this chart, okay? So you might have to refer back. It said if we define set B as the list of teams in the top 6, list set B. So they only want these 6 teams, okay? So these are the teams they want, so I'll let you pause the video. And you go ahead and find out what you think. Okay. So here's what you should have gotten. Okay. Now it says, does every team in set D appear in set B? So let me come back up here and remind you what set B was. Oh, what am I doing? Sorry, it's right here. Set D, that's what I meant. Set D are these 3 teams. University of Alabama, Ohio State University, University of Notre Dame. So does every team in set D appear in set B? So remember that was, I already forgot. Ohio State University, yes. University of Alabama, yes. And University of Notre Dame, yes. So every team that's in set D does appear in set B. So what does that mean? Well, if set D is in set B, then that means we have a subset. Okay? And that's how you write the notation. And then we're asked, does every team in set B appear in set D? That kind of sounds like, well, that's a dumb question. Well, of course, every team in set D appears in set D. These 3 teams are in set D. Well, do they appear in set D? Well, yeah, that's there. So it kind of seems like a dumb question. But what it's getting at is that it's getting to an important concept that you need to realize is that when we talk about subsets, is that every set is a subset of itself. So when we look at all of these teams, these 10 teams that we have, I can list the set U and say that U is a subset of itself. So that means are all of the teams in set U in set U? Yes, they are. Are all of the teams that are in set W, are all of these teams in set W? Well, yes, because that's what I have identified them to be. And here, are all of these teams that are in set B, are they in set B? Well, yes, they are. They're all there. So every set is a subset of itself. Okay? All right. Now, example 4, it says a snow cone stand suddenly ran out of lemon and blueberry. The only flavors they can offer now are grape, cherry, and lime. We can designate the set S as S being grape, cherry, and lime. So set S contains how many elements? Well, there are only 3 elements. Okay? And then part B, it said let S represent the set of available flavors and list the set using the roster method. So I'll let you pause. Okay, so we can say that S is exactly this, what we just did. It's those three flavors. Okay, if you can only choose two flavors, list each subset. So I'll let you pause. Okay, this is what you should have come up with. If you could only list the two flavors, so meaning you could only list two at a time, then you could either have grape and cherry, you could have cherry and lime, or you could have grape and lime. Okay? Any combination you choose. All right. Now, if you could only choose one flavor, part of the answer, list each subset. So pause the video. Okay. And this is what you should have come up with. So you just list them individually. Okay. If you decide that you do not want a snow cone, list a subset. So if I list the subset, what do you think it's going to be? If you don't want the snow cone, then I don't want anything. Now, it's not the empty set. It's you saying that you don't want a snow cone. Okay, an empty set would be if you chose a flavor that was not part of these three. Raspberry, that's not part of it. Okay. All right, now the set S, which has three elements, has a total of how many subsets? So remember this, the set grape cherry lime is a subset of itself. So that's 1, 2, 3, 4, 5, 6, 7, and then don't forget this one, it's 8. So I think I accidentally typed in 7, and it should be 8. Yeah. It's 8. So how many subsets are not equal to the original set? And which one would not be equal to the original set? So if it's equal, it has to have the elements in the original set. This one doesn't have anything in it. So that means there's only one that's not equal to the original set. Okay. All right, now, example 5, when subsets are not equal to the original set, they are called proper subsets. So our universal set are the numbers 1, 2, 3, 4, 5. A is the set 1 through 5, and B is the set 1 and 3. So draw a Venn diagram that represents the proper subset. So for A and B, they are both subsets of U. So in my universe, they go inside the block. But for A and B, notice that B is a subset of A. So B has to go inside of A, which contains 1 and 3. 5 is only in A, it's not in B, but notice that A still encompasses set B, which has the elements 1 and 3. So 1, 3, 5, it's still in set A, and 1 and 3 are still in B. So the numbers that we haven't talked about were 2 and 4, which means they go outside of both of these subsets. They are not part of A or B, but they are part of the universe. Okay. All right. Now this one, you're going to do this one by yourself. So if you look ahead, you're going to end up seeing the intersection. So when we talk about the intersection of sets, okay, so what this means is let A be the set 10, 12, 14, 15. Let B be the set 13, 14, 15, 16, and 17. So they want us to list the intersection of these two sets. Now, remember your intersection. Let me come back up here. Your intersection is a set of elements that are in both sets. So what numbers are in both sets? And so for that, you should see that numbers 14 and 15 are in both sets. Let's go ahead and, well, we can look at okay, that's one. Sorry about that. This is just driving me crazy. So we can look at part B. It says draw a Venn diagram that represents the intersection. So since we have an overlap, that means that our circle for A and B are going to cross each other like this. And we know that the ones that go inside are going to be 14 and 15. That's the intersection of these two sets. Okay, so notice that for set A, we still have 10 and 12. Well, they have to go in the A circle, but they're not part of the set of B. Okay, only 14 and 15 are included for set B. So that's why 10 and 12 go in the A circle, but outside of B. And then for B, 13, 14, 15, 16, 17, remember 14 and 15 are the two numbers that are common with set A. So again, that's why they're in the middle. But 13, 16, and 17 are only part of set B, not set A. Okay. Now here, they want us to list the complement of A. So what are the numbers that are not in set A? Well, here's set A, and all you have to do is just look in the B circle outside of set A. So that would just be 13, 16, and 17. And so you can do the same thing for the complement of B. Here's B. So what are the numbers that are outside of B? And so it would just be those two, which are 10 and 12. Okay. All right, so here's another one. So if A are these cities, B are these cities, and C are these cities, then find A, B, C, D. So the intersection of A and B. Intersection. What do they have in common? And the only two cities that they have in common are Chicago and Detroit for A and B. Okay. Now for B intersect C, B and C, what are the city or cities that they have in common? And they only have one, and it's Los Angeles. Okay. Now they want the intersection of A, B, and C. So for all three sets, what do they have in common? Uh-oh, I messed up. They are, this is supposed to have that supposed to be there. I'm so sorry. Oops. Yeah. Okay. Now that's correct. Okay. So what do they have in common? What do all three have in common? And they all have that LA, Los Angeles, is common to all three. Boy, I really messed this one up, guys. I'm so sorry. B and C. Yeah, that's right. No, that's right. B and C. What I did forget to do is to label this as set A, set A, B, and C. And I'll do that when I upload this so that you'll have those labeled. But they are color coded to match the set, so that should be good enough. But normally we do identify the circles with our capital letters. Okay. All right. And so you can see the last thing was to draw the Venn diagram for the scenario. So again, you just start filling in the intersections and then put the cities, where they go, respectively, where they go. Okay. All right. Now we talk about the last part, which are union of sets. Now remember, unions are where you want everything from your sets. If you're talking two sets, you want everything from both sets. Okay. So it says three experimental actually, let me back up. When the intersection of two sets is empty, the sets are said to be disjoint. So that means that there is nothing common between A and B. Then they are disjoint. Okay, so for example, the set of students who stop attending class, let's call that A, and the set of students earning A's are disjoint sets. Well, they're going to be disjoint because if you're not going to class, then there's no way you're going to earn an A. Okay, so this is what disjoint sets look like. That means they have nothing in common. Okay, so three experimental medications are being evaluated for safety. Each has a list of side effects that has been reported by at least 1% of the people trying the medication. This is a blind trial, and we're going to talk later about the different types of trials on experiments. So it's a blind trial, so the medications are simply labeled A, B, and C. The side effects for each is listed below. So set A, the side effects for medication A are nausea, night sweats, nervousness, dry mouth, swollen feet. The side effects for medication B are weight gain, nausea, blurry vision, fever, trouble sleeping. And then the side effects for medication C are dry mouth, nausea, blurry vision, fever, weight loss, and eczema. Boy, doesn't that sound nice? Okay. So now, part A, they want you to find A union B. So remember, unions is everything that is common. I mean, everything from both sets. It's the greedy one. You want it all. So pause the video and see what you come up with. Okay, this is what you should have gotten. Okay, now we're going to look at A union C. So sets the side effects from medication A and the side effects from medication C. So again, pause the video and let's see what you come up with. Okay, there's what you should have come up with. Now for these last two, because these are beginning to get a little bit more involved, but notice it says find A union B intersect with set C. Now you've already done A union B, so that's this. So you're going to take what part A has in common because this is the intersection. So you're going to take, this is part A, intersect with set C. So you're going to look through all of these side effects and see which ones are common with C. So C has dry mouth, but A union B doesn't have, oh, it does have dry mouth. So dry mouth is one of them. Nausea, there's nausea for A union B. Blurry vision, there's blurry vision for A union B. Weight loss, nope, this one has weight gain. And this one has eczema, this one does not have that. Oops. Okay, so this is all that you should have: dry mouth, nausea, and blurry vision. Okay. Now, this one, they want you to find A intersect B, union C. So first, you're going to take the intersection of A and B. So if you look at the side effects for these two for A and B, it's the intersection. So what do they have in common? And let me look at this, make sure I didn't do anything wrong. So they both have nausea. This has night sweats, but there are no night sweats for B. This has nervousness. There's no nervousness in B. Dry mouth, no dry mouth in B. Swollen feet, nope, no swollen B in B. So the only thing that they have in common is nausea. Now they want you to take that along with the union of C. The union is easy. That means you take it all, no matter what. So you're going to take nausea along with everything that set C has. Now, set C already has nausea listed, so we don't count it twice, okay? Which that's going to be an important concept later. But when we list this, go ahead and pause and see if you can. You get the same thing. Okay, here it is. Oops. End of the verse. So nausea, dry mouth, blurry vision, weight loss, and eczema. And guys, that's it. That's it for section 6.2. All right. Let me know if you have any questions, and I will answer them. All right. We'll see you guys later.